Hey there, Mr. Witherow here. Today we're going to end up talking about systems of equations. All right, so simply put, it's just two equations with two variables. Both equations will have x and a y in it. Our job is to find what each variable is equal to. So basically, we're going to solve for each variable. That's about it. How are we going to do that? Well, we're going to graph, or we're going to substitute, or we're going to eliminate. There's three different ways we can do this, and that's what we're going to do. We'll take one at a time. Today we're going to end up doing graphing, but we'll get to that in a minute. The last thing on this sheet is types of solutions. Well, we can have one solution, which is just a single point. In essence, it's where the two lines would cross, right? So that's why it's in an XY, all right? We can also have no solutions, and then the last one is infinitely many solutions. So there's three solution types that we're going to have: one solution, no solution, or infinitely many solutions. All right. Like I said, today we're going to talk about graphing. We're going to solve by graphing. And the way we're going to do that today is take a look at a couple things that we're going to need to make sure that we have in order. First, we got to make sure that the equations are in slope-intercept form. And if it would focus, you can see that. Is it not going to focus? Come on now. Focus, young Skywalker. I don't think it's liking me. There we go. Oh, back and forth. It did. It liked it. Oh, come on. Boo. Come on. Let's see what we can do here. Nope. There we go. All right, we'll see if it stays. All right, so we're making sure that the equations are in slope-intercept form. We're going to graph each line on the same grid, and then we're going to determine the solution. All right, so what do I mean by that? Well, first of all, you're either going to get one single point and where the lines intersect, right? So there's your single point. We can get no solutions because the lines are parallel. And then the last one is that infinitely many solutions, which just means that the equations produce the same line. All right, so there's your three: single point, no solution, or infinitely many. Let's take a look at it. All right, so here we go. Y is equal to x minus 8, and y is equal to negative 2x plus 1. Both of these are in slope-intercept form, so we can graph it. Let's zoom in on here a little bit. All right, so y is equal to x minus 8. So we go down to 8. 1, 2, 3, 4, 5, 6, 7, 8. We put a dot. That's our y-intercept. Our slope is 1 over 1 in the positive direction. So now I just put little dots, right? Now you can either do dots, or if you have a ruler, then you can simply just do the ruler. Boop. All right. And then what we're going to do is that we would have y is equal to negative 2x plus 1. So we go up to the 1. And we got slope is negative 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, or up 2 back 1, right? So again, you can either just do the dots, right? So we can see that this is where it crosses. This is where they intersect. So what is this point? This point is 1, 2, 3, and then down 1, 2, 3, 4, 5. So our point or our solution is 3, negative 5. And that's what we would write, 3, negative 5. All right, so again, I don't care if you write or give the whole line or just the points that make up the line, however you want to do it. Okay? All right, let's try another one. We can try another one in this form here. Zoom back out a little bit. Okay, so the first things first here is that we have to make sure that it is in y equals mx plus b form. It looks like the first one is not. So let's look at that and let's work on that. X plus 2y is equal to 4. So for us to get this into y equals mx plus b, I have to move the x term over. So I get 2y is equal to negative x plus 4. And then I have to divide everybody by the coefficient on y, or the number that's attached to y. So that means I get y is equal to negative 1/2 x plus 2. So here is one equation. And then here's the other equation. And if you notice, they are the same equation. How about that? So we have two equations that basically produce, right, the same line. So up 1 over 2, down 1 back to, or forward 2, right? So it's going to be like this, and then that's our line right there. So what happens here, our solution set, right, is going to end up being all real numbers, because anything, any x and any y will make this true and to make this true. So what we would say is all infinitely many solutions, because they're the same line. That's what we're going for, is that they produce the same line. So you can make the little infinity sign or call it infinitely many. Oh, you can't see that. Many solutions. There you go. All right, so that's what it looks like. Infinitely many solutions when they have the same line. All right, last but not least, we have this here, and we make sure that they are in y equals mx plus b form. The first one is, the second one is not. So let's solve that one. Let's get that one by itself. So we're going to subtract the x term again. We bring down the negative y, and that's going to be equal to negative x plus 2. And then since we have a negative y, we have to divide by negative 1. That gets this to be a positive y. This is a positive x, and this is a minus 2. So we have this. We're going to go ahead and graph that. So negative 2 is our y-intercept. Our slope is 1 over 1. All right. So again, if you want to leave it with dots, or if you want to draw the line, that's fine. However you want to do that. And then the other equation is the original one way up here. And so we're at plus 5. 1, 2, 3, 4, 5. And again, it has the same slope. Hint, hint. Same slope. What lines have the same slope? You guessed it. Parallel lines. So since we have parallel lines here, that means these lines don't ever cross. They don't ever intersect. That means we have no solution. All right? Whoop. No solution. We do not have any number that we can plug in for x and add 5 2 to get y and subtract 2 2 to get the same y. That's what happens. So systems of equation, when we graph, we are going to graph them on the same line, same grid, and we're looking for where they either intersect, where they produce the same line, or where they never intersect because they're parallel. All right? Keep making math fun.